Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about thermodynamics. You know my friend, the word thermodynamics means a study of flow of heat. The word thermodynamics means a study of flow of heat. What is the definition? The branch of physical chemistry which deals with the energy changes accompanying a chemical reactions. Now term used in chemical thermodynamics. System, surrounding, types of system, open system, closed system, isolated system. Surrounding, system and boundary. You can see the boundary. Now, physical properties of a system. Intrinsic properties, example temperature, pressure, viscosity, surface tension, refractive index, specific heat, density. Extensive properties, mass, volume, energy, heat capacity, entropy, Gibbs free energy. Thermodynamics process, isothermal process, adiabatic process, isobaric process, isochoric process, reversible process, and irreversible process. Now, internal energy. Every substance possesses a definite amount of energy, which depends upon its chemical nature, temperature, pressure, and volume. This is called internal energy. So, E total is equal to translation, rotational, vibrational, electronics, and N and E. So, del E is equal to E2 minus E1. Now, laws of thermodynamics. First law of thermodynamics or law of conservation of energy. First, stated by Meyer and Helmholtz in 1840. Energy can neither be created nor destroyed, although it can be transformed from one form to another, or the total amount of energy of the universe is constant. Now, first law of thermodynamics, you can see heat transfer and work, that is E is equal to internal energy. So, E2 is equal to E1 plus Q1 plus W, E2 minus E1 is equal to Q plus W, E is equal to Q plus W. So, E2 is equal to E1 plus Q plus W, E2 minus E1 is equal to Q plus W, del E is equal to Q plus W. If work is done by the system, then del E is equal to Q minus W. So, plus Q, heat absorbed by the system, minus Q, heat liberated by the system, plus W, work done on the system, minus W, work done by the system. Enthalpy and entropy change. Enthalpy is the amount of heat stored in the system under particular condition and is termed as heat content of the system. H is equal to E plus PV. Enthalpy change, del H is equal to H2 minus H1. On constant pressure, HP, EP and VP. Heat absorbed by the system on constant P, then HR, ER and VR is just consider B. So equation B minus equation A, that is del H is equal to del E plus P del O. So a spontaneous process. The spontaneous processes are those that can proceed without any outside interconventions. Processes that are spontaneous in one direction are non-spontaneous in the reverse direction. Now entropy. Entropy can be thought of as measure of the randomness of the system. Gas greater than liquids of entropy and very less in case of solid. So entropy can be thought of as a measure of randomness of the system. Like total energy E and enthalpy H, entropy is a state function. Therefore, del S is equal to S final minus initial and del S is equal to Q reversible by T. Now, second law of thermodynamics. The entropy of the universe does not change for reversible process and increase for a spontaneous process. So, del S universe is equal to del S system plus del S surrounding greater than equal to 0. So, del S greater than 0, irreversible, real or spontaneous. Del S total is equal to 0, equilibrium, reversible or ideal. Del S total less than 0, non-spontaneous process. Now, second law of thermodynamics. Third law of thermodynamics, Nurse 1906. The entropy of a pure crystalline substance at absolute zero is 0. So, difference in first and second law. First law is concerned with the accounting of the various kind of energy involved in a given process. Second law is concerned with the availability of the energy of a given substance system for doing useful work. So combining the first and second law of thermodynamics, Gibbs in 1878 gives the relation del G is equal to del H minus T del S. So free energy or Gibbs free energy, which is represented by G, in 1878, J.W. Gibbs created the free energy function by combining the first and second law of thermodynamics. So del G is equal to del H minus T del S. Free energy change del G, G1 H1 S1 and G2 H2 S2. According to Gibbs, G1 H1 and S1 and G2 H2 and S2, where T is constant. So equation B minus equation A. Now, for a spontaneous process, del S total is equal to del S system plus del S surrounding. Del S total is equal to del S system plus minus Q by T system, or QP is surroundings is equal to minus QP system. So del S total is equal to del S minus del H by T. QP is equal to del H. Multiplying of minus T on both sides, minus T del S total is equal to minus TS and del S plus del H. So minus T del S is equal to del H minus T del S. So for Gibbs free energy, del G is equal to del H minus T del S for a spontaneous process. Now, predicting sign of del G in relations to entropy and enthalpy in entropy. Del G, del S, del G, minus plus always negative spontaneous, plus minus always positive non-spontaneous, negative spontaneous at low temperature, positive spontaneous at high temperature, positive or spontaneous, positive non-spontaneous at low temperature, negative spontaneous at high temperature. Now, the conclusions of today's lectures. The direction of radiation, whether from left to right or vice versa. The accomplishment of work, whether useful or not. Whether the energy for driving radiation must be delivered from one external source. So this is the reference. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.